Hello everyone, and welcome to lesson 6.8, the final lesson in chapter 6. It is on writing linear functions. In this lesson, we're going to talk about how to take graphs of equations and write the actual math equation for it. So from the graphs, we will be able to pull enough information to write equations. Now, the big thing to remember here in this section, and we'll write it in pink, is that anytime we are writing equations of lines using graphs, we will always be using the y equals mx plus b format, which is our slope-intercept form. That's nice for us because as long as we can find what the slope is and as long as we can find what the y-intercept is, we're in great shape. So let's look at our first example. We have this line here, and since we know we are using y equals mx plus b format, the very first thing I need to look for is the y-intercept. Well, the y-intercept is where the graph crosses the y-axis. My y-axis is running up and down. My x-axis is running left and right. So we can see that it crosses right here. And if I were to go ahead and label my lines, you can see that our graph paper helps with that. 1, 2, 3, 4, 5. I'm just drawing everything in for you guys so you can see where every number exactly is. All right. So we've drawn that dot in there, and what we can tell is that this dot, I'm going to color over it in green just to make it stick out. That dot is at 1, right? So that means our y-intercept is at 1. It's also a solid point on the line, so we have a point of 0, 1. Okay, so now what we need to do, once we've found the the y-intercept, we know where that is, we know it's at positive 1, all we have to do is search the graph for another intersection point. And when I say intersection point, right, it's nice that I have graph paper here, but notice how the graphs have these light dotted lines on them. I'm going to highlight them in yellow just so you guys can see. But notice how we have all these vertical lines going here and we have all these horizontal lines kind of on the paper to help guide us. When I say an intersection point, I'm talking about these crosses where they meet. Right? We need to find one of those points where the graph goes through. Does it hit something exactly? And noticing the graph, I can see that right on the x-axis at 2, it crosses again. Now that's important because those are solid, even, nice whole number points, nothing with decimals or fractions that we have to deal with. And that helps us because if I know where 2 points are on the graph, I can just count what the slope is. Well, my slope is going to be, from left to right, I'm going up 1 spot, and I'm going right 2 spots. So to get from one point to the other, I go up 1 and right 2. Remember that slope is rise over run. So since I'm going up 1 and right 2, those are positive 1 and positive 2, I know that my slope is 1/2. Additionally, going back to where we started, if I know that my slope is 1/2 and I know that my y-intercept is a positive 1, I can now write my equation. Y equals 1/2 x plus 1. So, it's not super complicated to find the equation. It's just being able to count and calculate your slope, and then also being able to find your y-intercept. All right, so let's try that process again on number 2. In this case, the line's going in a different direction. That doesn't matter. I still just have to go through the same process. So the first thing I'm going to do is try to find my y-intercept. Okay, cool. I see it crosses here. It crosses at -1. So I know that there is my y-intercept. Now I have to find another spot where the graph crosses. Well, I can see that the graph crosses a good intersection point up in the top left over here. And now all I have to do is just count the spaces between the points to find the slope. No need in messing with formulas. So I go down 1, 2, 3, 4, 5 spots here. So I go down 5. And then I go to the right 1, 2, 3 to get to my next point. So I go down 5. I go right 3. Since rise over run is my slope, that's going to be -5 over 3. And I'm able to calculate my slope. That means that my equation is going to be y equals -5/3 x minus 1. Just as easy as plugging in numbers once you find them. Okay, moving on. We'll take a look at our last example of the chapter. It says, determine the equation of a line that passes through -5, -5, and 10, -5. Well, they've given me 2 points, but they haven't given me a slope. That probably means I've got to calculate slope. We've done this before in a couple sections ago. So we go ahead and label our points, x1, y1, x2, y2. And we use our slope formula. M equals y2 minus y1 over x2 minus x1. That's going to be equal to -5 minus -5 over 10 minus -5. Okay. Simplifying, because we got some double negatives in there, that's going to give me -5 plus 5 and 10 plus 5. Well, from here, we end up getting -5 plus 5 is 0, and 10 plus 5 is 15. And as we've covered before, 0 over 15 is just a slope of 0. So we know what our slope is. Now, we've encountered this before, and we know we're probably going to get a horizontal line, right? Anytime we have 0, right, what do? Zeros are horizontal lines. So we just go back and we check. Oh, we got some matching numbers here. Those matching numbers in each point are on the y. So that just tells me that my equation of a line is y equals -5. That's kind of a kickback to our lesson on horizontal and vertical lines. Sometimes they give you the point, you get a 0 slope, find the matching numbers, and the variable that goes with it. All right, guys, so that's a wrap on Chapter 6 and Lesson 6.8. Hopefully you're in good shape to head towards the quiz. You're in really good shape to write an equation of a line given its graph. But if not, if you need more explanations or have any clarifying questions, please reach out to me and let me know.